Hello! In this presentation, we will discuss primal and dual views for planning energy investment under uncertainty. My name is Felipe Atenas, and I am a PhD student at the University of Campinas in Brazil. The problem that we study is a two-stage stochastic convex programming problem in which we minimize the expected cost of a convex function subject to, on one hand, convex constraints, including the technological constraints for different power plants, and on the other hand, the non-anticipativity constraint. This last constraint tells us that we cannot use information from the future because uncertainty is progressively revealed through stages. Because this problem may be of huge size even in a two-stage case, our goal is to decompose the problem using its structure. In particular, we want to decompose for different scenario realizations and for different technologies in the power system. One option is a dual primal approach in which we decompose the original objective function for different scenarios by using the progressive hedging algorithm. By doing so, we obtain different scenarios of problems with coupling constraints because we have the demand supply constraint in an energy optimization problem. Then, by solving the dual scenarios of problems, we can solve different problems for different power plants with a proximal bundle method. Another option is a primal-dual approach corresponding to an inexact progressive hedging with bundle features. First, we relax the non-anticipativity constraints, following the progressive hedging original approach. Then, we can solve the dual problem with a proximal bundle method by minimizing the augmented Lagrangian in primal variables with fixed dual variables. In this problem, the primal variables are the substitution multipliers. Then, we can define the aggregate subgradient using the primal information available in the bundle, and finally, we can update the dual variable using the progressive hedging rule. In this manner, we can introduce a stopping test measuring primal feasibility through the aggregate subgradient T hat and also an estimate of the duality gap using the available information. The price to pay is that we no longer have convergence of the whole sequence, but convergence of subsequences whenever cluster points exist. Following the ideas of bundle methods, then we call an oracle, which can be inexact, at the new candidate W plus for the dual sequence, and then we check using that information if this point provides a sufficient decrease of the dual function. If there is sufficient decrease, then we update the zeroth step sequence, and if not, we make a null step.